Hi, in this video we'll be talking about an application. So let's get into the problem. So you're given an array A of size n. You need to answer Q queries of the form $LR. Okay, and what is this LR that is given to you? So you need to find the value of the expression modulo 10 to the power 9 plus 7, and the expression is A of L plus A of L plus 1 multiplied by 2 plus A of L plus 2 multiplied by 3, so on up to A of R multiplied by R minus L plus 1. So as you can see, we are basically having a sequence where each of the value in the array is getting multiplied to its corresponding position in the original sequence between L to R, right? So A of L gets multiplied with 1 because that is the first element in L to R. A of L plus 1 gets multiplied to 2 because it's the second element in the sequence, and so on, right? So we need to find the value of this expression. So let's have a look at the example of the query. So you are given this array and you need to find the value for 2 to 4, right? So 2 to 4 would be this range. We are assuming that the queries are coming in 0 indexed. So this range, right? So if we try to calculate the value for this, it would be A of L. So that is 9 plus 4 times 2 plus 1 times 3. So that is 9 plus 8 plus 3. That comes out to be 9 plus 3 is 12 plus 8 is 20. So you have 20 as the answer for this query, right? And there are Q such queries. Now you can obviously, for each of the query, go ahead and loop in the array and find out the value, right? So you can just loop from I equal to L to R, and for every index you can just multiply it and add to a answer variable. But that would take an order n for every query, right? So if we loop, we get an order n. So order n if we loop, right? So and in total for Q queries, that would be order n times Q. So now we want to do better than that. How we can do that? So for that, let's have a look at the expression first. So this is the expression, right? Now how can we rewrite it somehow so that it can help us? So first of all, let's write it in the form of summation. So let's say we write it in form of I equal to L to R. So what is this summation in a generic I terms? So how do you write the general expression for this? So we'd have A of I, right? Because for L to R, A of I is there, and every A of I is getting multiplied with I minus L. So for the first term, I will be L, this will get to 0, so you add 1, right? So you can see that this is the term that is being multiplied with all the ith terms in the sequence, and if you even put I equal to R, that satisfies the last term, right? So this is the general expression. Okay, now we can split this internal part of this expression, okay, this part, into A of I times I, right, plus 1 minus L. There is 1 over here and minus L over here, so we keep that part together and we multiply it with A of I, right? Okay, and there is this summation that is being carried on. So from now on, we assume that this summation is from I equal to L to R. Now we distribute this summation over these two terms, okay, and we can write it as summation of A of I times I plus 1 minus L is constant with respect to I, right? So we can write it outside the summation, right? So we can write it this way. Now this is from L to R, right? And we need to find the value of summation of A of I from L to R. Now if you recognize, this is the exact statement for prefix sum, right? That if you want to find out the value of sum of a range, you can find that in order 1, using prefix sum, right? So if you have the array A, if you build a prefix array, and from that you can easily get an sum of values of the range L to R using order 1 from the prefix sum. This is the term that we have not yet encountered, right? So let's introduce a new variable. Let's introduce a new variable, that is b of I. Okay, let's try to introduce a new variable b of I, which is equal to a of I times I. Okay, nothing fancy in this. So this becomes, this part over here becomes summation of a of I multiplied by I, right? So that is what is over here, and we can just replace that with bi, right? Can we replace that with bi, because that's what the definition of bi we are using, right? So L to R, right? So we need to find the sum of bi's from L to R. Now you can see that b of I doesn't depend on L and R, right? This is only dependent on I. So we can pre-process the b values for all the indexes from I equal to 1 to n or 0 to n minus 1, and whenever we need this value of summation of a of I times I, rather we can query out the summation of bi values from L to R. And since this is a static array, because as a of I is static and I is also dependent on only on index, so this is also a static array, so we can also find the range sums of this using a prefix sum. So we can also get this value using a prefix sum in order 1, this sum, right? So we are done with this part and this part. So we pre-build a prefix sum for A and get the sum of this in order 1 multiplied with this number 1 minus L, that is for this query, and then for the bi part we also maintain a prefix sum, get this sum in order 1 and add them together to get the answer for the original question. So you can get this answer from this expression, and we just use the prefix sums into this. So let's have a look at what we are doing. So we have this original A array. Okay, from this we are going into this using a transformation, that is b of I will be equal to a of I times I. Now that's just looping over I equal to 0 to n minus 1 and just filling in the values from this array. So that's just an order n, right? A simple loop. And once we build this, now we have two arrays A and B. We would be needing sum over ranges for A and B. So what we can do is that we can build two different prefix sums, one prefix sum over here, one prefix sum over here, and use these two prefix sums whenever we need them in this expression, right? So what about the time complexity of this method? So you are given this A. So to build this B, you just need to loop over A from 0 to n minus 1. So that's an order n, right? So order n over here. Now building this will take you order n. We know that prefix sum takes order n to build because that's a new n array. Building this will also take order n because that's again a prefix sum. Okay, and then for every query, you just look into the sum of a of I, so that is already available, and in prefix sum you can get the sum of range in order 1 and summation of range of bi values. In prefix sum, this p2 array, from that you can get the value of summation of L to R bi in order 1. So it takes order 1 for every query, so that is order q across all the queries. So total complexity would be order n plus q. So n is for all pre-processing and q is for this. Now one thing that you can do to not declare too many arrays is that you can first make this b array, and you can also make the prefix sums, these two prefix sum values in place in A and B, because we only need the sum of ranges, right? So you can always get the values from these prefix sums. You no longer need this A and B array. So you can create the prefix sum in place in the array A and in B. And for that you just loop the prefix sum building loop in the array A itself, because for building prefix sum you only need the element and its previous prefix sum. So if you loop in this order, you can build that easily. Okay. So that's all for this video. See you in the next one.